Are you able to hear me?
Yes, sir.
Okay, okay. So let me share my screen quickly. Are you able to see my screen?
Yes.
So yesterday we have discussed about Spark architecture, right? So how actually Spark executes internally and how our job after the job submission, how actually Spark executes our job, right? So that is what we have discussed yesterday, and we have seen the Spark model, right? How actually Spark provides data processing APIs, Spark Core, Spark AP, Data Frames API, Spark SQL, Spark Streaming, mlib, graphics, right? So these are all different APIs that Spark will provide, and remember, Spark is not a data storage layer, so it is only for data processing. It doesn't store any data. Okay, so that is something that we need to remember. Okay, so today we will try to see the practical things related to RDDs. Yesterday we have seen what is RDD, right? So what is RDD and how to create RDD, right? So we have seen resilient distributed data set. So what is resilient, fault tolerance, and then what is distributed? So it is distributed across different nodes. And then what is a data set? End of the day, it's a collection of all partitions, so that it's a data set. And then we have seen RDD properties: immutable, lazy evaluation, and then type inferred. So these are the things that we have discussed yesterday. And today we will see transformations and actions. So yesterday we have discussed the definitions of transformations and actions, right? So transformations are something which are actually used to transform your RDD. Okay, and these transformations will return a new RDD. Okay, these transformations will return a new RDD. So these are the things that we need to know to work with RDDs. Okay, when you create a RDD from a file or from a data collection, you should know how transformations will work, and you should know how actions will work. Okay, so today we will see all these transformations and actions in a practical way. So we will try to execute and then see. Okay, okay, and then we will try to understand how actually the Spark is working for these transformations and actions, right? So let's quickly jump into the practical things of RDDs. Okay, so today we are going to see RDDs practical session. Okay, so for that we need a cluster. Okay, so I'm just trying to start my Vertex AI notebook. Okay, so I want to create my cluster. So I will start my Vertex AI notebook. Okay, so now a majority of you may get confused when we were discussing about these RDDs, partitions, and all. It's no need to get confused. So here the major thing is the distributed parallel processing. Be very clear. Remaining everything follows under your Python. Okay, so remaining everything that we are writing, right? So everything that you are writing is under your Python notation. Okay, so the only thing that you need to understand is you need to know the internals of distributed processing. Okay, so how actually the executors are working, how tasks are distributed to executors. These things you need to know. Remaining everything remaining everything is only in Python. Okay, fine. So Today we once we create the cluster, we will try to see the practical implementations of our RDDs. Okay. Now, anybody have any questions in yesterday's session, guys? After you explored any questions you got in Spark architecture? Everybody clear?
Yes, clear.
Any questions, queries, confusions? Please ask. Okay. So
Yes.
hope everything is clear. Uh,
Yes,
yeah.
clear.
Anybody have any questions? Yeah. Okay. Fine. So let us quickly understand the practical things. Let me quickly create the cluster. So I just started my notebook. Yeah. Hello. Are you able to hear me, guys?
Yes,
Yes.
Okay. Okay. There was a power cut. So reshare my screen. Yeah. Are you able to see my screen?
Yes, sir.
Started my notebook. Okay. So after I started, so I'm going to create my cluster. Okay. So I think everybody knows how to create the cluster, right? So G Cloud data prop clusters create cluster name, enable component gateway, and all your parameters that you need to pass. Okay. And then create the cluster. So this command will create the cluster. Your workspace. So I'm just pasting the command. So here I am using E2 standard 2. So that is one of the machine type, general purpose machine type. Okay. And I'm using as master boot disk 50 GB and then worker boot disk 50 GB. Number of workers I'm taking as 2. So that means that it's a 3 node cluster. Okay. Out of which 2 workers and 1 master. Okay, and the image version that I'm using is 2.0.47 Debian 10. Okay, and the project bucket service account. Okay, so these are the configurations that I'm passing to my cluster creation command. Okay, so once this cluster got created, then we will see how we can work with Spark in that cluster. Okay, so before going to that, we will see we will see two ways of working with Spark, right? So let me quickly explain you that. Okay. Okay, so in real time, how actually we implement this Spark things, right? So let us quickly understand that. So there are two ways, guys. One is shell based, shell based uh, programming. Okay, another one is application based programming. Okay, so in real time, we majority of the times we use application based programming. Be very very clear. Okay, and the shell based programming is only for our testing. Let us take an example. You want to test a particular transformation, and then you want to observe the result how it is coming. Then you can go for shell based programming. Okay, but initially to start with, we will go with the shell based programming. Then we will see the application based programming, so that you will understand very clearly how it is working. Okay, so first we will focus on shell based programming. Okay, and then we will focus on application based programming. So when we go for the application based programming, so we need to build this application. Okay, we need to build. So we will develop the application, and then we will build the application, and then we will generate a wheel file. Okay, so like Java, we will get jar file, right, out of a Java program. Once we build it, entire code will be packaged into a single file. Okay, that file is a jar file in Java. But in Scala, it is all in Scala also it is a jar file. But in Python, it is a wheel file. Okay, it will get a single wheel file. Okay, once we have this wheel file, right, then we will deploy it. Okay, then we will deploy it. Okay, deploy wheel file with all the parameters, all the input parameters. If my application have any input parameters, I'll pass all the input parameters to my wheel file. Okay, and in this shell based programming, you don't need to do anything. It's just direct step by step run. Okay, that's it. Okay, immediately you will be able to see the result. Okay, and this application based programming is for a functionality. If you want to implement a big functionality like a project level functionality, then you'll go for the application based programming. Okay, so now let's quickly see our cluster got created. Okay, so we'll start with the shell based programming, because that will give you clear picture on all the transformations, and then we will quickly jump into the application based programming. End of the day, you will be writing applications in your real time projects. Be very very clear. Okay, okay, so I'm just quickly opening my cluster, and then I open my Jupyter lab in the cluster. Okay, so once you opened your Jupyter lab, if you quickly see here, I have a shell-based environment already created in the Jupyter lab. Okay, so that is Pyspark. Okay, so this icon, right? So you can click this icon, and then you can open your Pyspark shell. Okay, so now let us understand what is Pyspark, right? So in Spark, right? So Spark will support multiple different languages, correct? So it supports Java, it supports R, it supports Scala, right? So when you are using the Spark framework with Java programming language, we call that as Java Spark. Okay, when we are using Spark framework with Scala, then we call it as Scala Spark. When you are using Python as your programming language with Spark framework, Spark is a framework, guys. So it's a framework which have inbuilt distributed computing functionalities. Okay, in by using any of the programming language like Java, Scala, Python, or by using any of the programming languages, you can utilize that framework and write your application or write your functionality. That is what we call it as a using Spark framework we are writing program in Python. Okay, so that's what PySpark. Okay, so if it is a R based Spark, then we'll say Spark R. Okay, we'll say Spark R. So that is about PySpark. Okay, so you should know we are using Python to make uh, to make use of Spark framework. Okay, we are using Python programming language to make use of Spark programming or Spark framework. Okay, so I'm just clicking in the PySpark thing. Okay, so your notebook got opened. Okay, so I have few examples, I guess. Let us quickly see. Okay, yeah. So here, if you see, I have all the examples. Okay, so let us quickly understand the first and foremost thing is the Spark session object. Okay, you need to create your Spark session object. Okay, Spark session object meaning. So this is the inbuilt Spark session method. Okay, that you need to import from pyspark.sql, import Spark session. This is the first and foremost step that you need to do if you want to start with the Spark. Okay, Spark equals to, see here, it's a Python variable again. Remember, it's a Python variable, and you are calling a Spark session object dot builder dot app name. What is your application name? You are giving your application name. Okay, you are giving your application name, and you are saying get or create meaning if your application have already a Spark session object, then it will get the existing one. If it is not, it will create the new one. Okay, so that is about Spark session. Along with this app name, you can pass lot many things here. You can pass configurations, you can pass different arguments in your Spark session, right? We will see all of them, but as a first step, this is how we will create your Spark session, a simple Spark session object. Okay, now your Spark variable is an object of a Spark session type. Be very clear. Okay, now why do we need to create this object? Because everything, all the methods that you have are under your Spark session object. Okay, and your RDD based methods, your data frame based methods, all the source readers, right? All the data reading methods are available under your Spark session. Okay, now we have created the Spark session. Great. And the second step is how to create an RDD, right? So yesterday we have discussed, we have two methods, mainly two methods to create a Spark RDD. One is parallelize, Spark context dot parallelize. Spark context is an object again, okay, which is under Spark session. Okay, be very clear. Spark context is an object which is under Spark session. So these two things falls under driver. Be very clear. Spark session and then Spark context, these two are your driver service components. Be very clear. Okay, we know what is a driver, right? It's a master service, right? So Spark session and Spark context objects are falls under driver service. Okay, now this driver service will be running in your master node. Be very clear. Okay, now once you have the Spark session created, so these are how we are actually implementing them programmatically. Okay, this is that thing you need to observe here. Okay, we know driver is a master service. So under driver service, what are the things that are running in and how we are creating them programmatically? Okay, if you want to work with Spark, you need a Spark session object. Spark session object is the entry point for your Spark application. Be very clear. Spark session holds all your environment configuration of your Spark. Okay, and also Spark session holds all the data reading functionalities or data reading methods the inbuilt data reading methods, inbuilt RDD creation methods, everything is will be under Spark session. Okay, these are the things that you need to understand. So now once you created your Spark session, here in the next step we are creating a RDD, resilient distributed data set in Spark using Python. Be very very clear. Here the first step is declaring your data collection. Parallelize is a method or a function. We use this function to create a RDD from a data collection. Be very very clear. Okay, if you have a list, or if you have a list of dictionaries, or if you have a list of tuples, if you have a list of dictionaries or
Yes, sir.
tuples, then if you want to create a Spark RDD from that data collection, then you will use parallelize method. Okay, where this parallelize method exists, this parallelize method will be available under your Spark context. Okay, and where your Spark context will be available, your Spark context will be available under your Spark session. Be very very clear. Okay, these are the things that you need to understand, guys. Okay, so now to access your parallelize method, you need to go from the Spark session, Spark dot, see here, Spark dot, what is your Spark now? Your Spark session object. Okay, Spark dot, under Spark you have a object, or you have a function called Spark context, and under that you have parallelize method. Okay, now you have your data, which is actually list of integers, and you're passing that data variable to the parallelize method. Okay, now what will happen once you execute it? Okay, it will create the RDD. Okay, it will create the RDD. Okay, now if you want to see what is there, what is the content in my RDD. Okay, if you want to see what is the content in my RDD, you can use RDD dot collect. Collect is the method on top of the RDD to show you what is the content of that RDD. Okay, now remember this collect functionality is comes under action, right? Because it returns the data, it returns the result. Okay, now when you use this collect, what will happen, it will go and collect all the output from all the executors, and then it will pull the data to the driver. Okay, your driver program will be running in the master node, correct? Now what will happen once you execute your collect, it will go and then extract all the partitions contents or data from the executors to the driver. Okay, so remember, when you are dealing with very huge volumes of data, using collect is not at all recommended. Be very very clear. Okay, the reason being, your master machine will be overloaded if you do collect. What it will do, it will go and collect the data from all the executors that are there, from all the worker nodes, from all the executors. It will go and it will collect the data. Okay, and then it will place it in the driver memory. Okay, it will place it in the driver memory. So that is the major problem. Let us take an example. You're processing 1 terabyte data, and if you use collect on top of it, you assume how your master node will react, right? So for a smaller data, it is okay. So we are just dealing with small amount of data, so it's okay to use collect. But for bigger volumes of data, keep this in mind. We should, I mean, it's not recommended to use collect. Okay, so fine. Now, the first and foremost is creating the RDD using the parallelize method, and then looking at what is there inside the RDD. Okay, so now when we execute it, so see here your Spark program ran, and then it has given the RDD content. Okay, now you can ask me what is the difference between data variable and then an RDD variable. Okay, anybody answer, guys? What is the difference between, see, my data variable is also looks same, my RDD is also looks same. What is the difference? Answer, guys. Anybody? Anybody? What is the difference between the data variable and RDD variable?
Data data variable, it is not immutable.
Yes, good. I mean, data variable is immutable, but
Yeah, yeah.
RDD is
RDD
immutable.
data variable is immutable.
Yeah, it is immutable. Great. Any other answers, guys?
And RDD, it will store the data in a memory so that it execution will be fast.
Okay, great. Next. So, okay, so understand the difference, guys. So, data variable is your Python variable. Be very, very clear. Data variable, here the variable name is data, right? So, data variable is your Python variable. Okay, but the variable named RDD is not a Python variable which is restricted to your machine. Or let us take an example. Here I have a Python machine. I have a Python kernel. Okay, let me see. Okay, so this is, let me go to this terminal, right? So this is my machine. Okay, jobs cluster master machine, right? So I'm in the master machine. So if I create data variable, so the data variables data will be stored in this machine only, in this machine only. But if you see here, your RDD, this RDD's data will be splitted and stored in multiple different nodes. Okay, all the workers that we have, right? So it will be splitted and stored in the multiple different partitions. Okay, so internally what it will do, your RDD will read this data variable and split it into multiple partitions. Be very, very clear. RDD will be having multiple partitions. Okay, multiple partitions. Each partition is the chunk of your collection. Okay, each partition is the chunk of your collection. So it will take your entire data collection and it will chunk it and make it partitions and store it in multiple different workers. Be very, very clear. That is what RDD meaning, correct? So see here, in all the worker nodes, each and every chunk will be stored with respect to your data, right? So now if you see data variable is limited to your drive, I mean master machine, because you declare that variable in that machine. So Python is a single machine service. It is not a distributed framework, right? We know Python is not a distributed framework, right? But your RDD is a distributed data set. Be very, very clear. That is the major difference. Okay, it is distributed across all the worker nodes, right? So you need to understand that difference, guys. You need to understand the difference. The Spark RDD is a distributed data collection. Be very, very clear. And the data will be distributed across all the worker nodes in terms of partitions. Okay, guys, clear? Any questions? Come on, guys, speak up. Any questions?
Clear. Clear.
Okay, Fine. So that is the major difference. Now, okay, so I want to see what is there in my RDD. So you can use rdd.collect. So this is a action. Okay, this is a action. So when you trigger an action, then only your Spark program will run. Be very, very clear. Otherwise, it won't run. Okay, so it won't run. So you need to trigger an action to see or to make your Spark program run. Okay, fine. Now we have created an RDD from a parallelize method and using a collection. Okay. Now let us take an example. I have data in a external storage system called GCS. Okay. See here, this is my GCS file path wherein I have a text file that is available. Okay, and I want to create RDD from the text file. Okay, I want to create the RDD from the text file. So how you will create the RDD from the text file? By using the text file method. By using the text file method. Okay, and again, this text file method is available under Spark context library, and this Spark context will be available under Spark session. Okay, now the text file method will take your file path. Okay, the text file method will take your file path. Now this file path you'll pass, and then you'll create your RDD. Okay, see here I'm just running this, and then your file will be read. See here, this is your file content. Okay, this is your file content. Okay, two ways of creating your RDD using the Spark dot Spark context dot text file, and then Spark dot Spark context dot parallelize. Okay, now in the case of parallelize, you will create the RDD from the collection. Okay, data collection. It may be a list, or it may be a tuple, or it may be a list of tuples, whatever it is. If it is a data collection, you can create your RDD from the data collection using the parallelize. If it is an external file, you can create your RDD by using the text file method. Okay.
Will this work out for all the kinds of files?
No. It is only for text files and log files and zip files or .zz files. Okay. And you create RDDs only for the unstructured files which does not have schema. Be very, very clear. Okay, RDDs are mainly meant to process files which don't have schema at all. If your files have schema, then you will go for data frame API. Okay, there you have inbuilt readers: spark.read.csv, spark.read.parquet, spark.read.org, spark.read.json. Okay, you have default readers there. So there spark.read.csv of your CSV file path will return the data frame, not RDD. So these are two different APIs of processing your data. Okay, so we are started with RDDs. Okay, then we will go for data frames. In our coming sessions, we'll definitely go for data frames, and it doesn't mean that you won't be able to process CSVs with RDDs. Okay, remember, your Spark core API, your Spark core is the responsible thing for everything that is running in the Spark. Okay, Spark data frames are the abstraction of your Spark core. So meaning you can actually write data frames for your flexibility, for your easy coding, but internally, remember, Spark executes them in terms of RDDs only. Okay, in terms of RDDs only. So RDDs are the core abstraction of Spark. Okay, you can process your CSV files also, but you need to use only text file method to read them. You don't have default readers in RDDs. Okay, Clear, Sai?
Yeah, clear.
Okay. So now I'm having a text file in GCS. See here, I used text file method to create my RDD. Okay. So now let us quickly see what are all the transformations that we have, how we can transform our RDDs. Okay, how we can transform our RDDs, and then how what are all the different actions that we have. So today our focus will be transformations and actions. Okay, what are different transformations that we have on top of the RDDs? What are different actions that we have on top of the RDDs? So today we will see that. Okay, so now once your RDD is created, you can use your transformations. The first and foremost transformation that we are seeing is the filter. Okay, on top of the RDD, you can use a filter transformation. Okay, to filter your RDD data. Okay, let us take an example. You got a use case of processing a text file or processing CSV file. Okay, and you need to apply some filter conditions. Okay, so in that scenario, you can use your filter transformation on top of the RDD. Okay, see here, I'm just using parallelize method and I'm using a range of 1 to 10. So we know Python. Okay, so what is this range will do? It will create a data collection from 1 to 9. Correct. So now this data collection will be created as a RDD and stored in the a variable. Okay, and the second step, if you see, b equals to a dot filter. So I'm using RDD dot filter. Filter is a transformation you can apply on top of the RDD. Okay, and then see here I'm using lambda x. So what is this lambda? So it is anonymous function. We call it as anonymous function, a function without a name. Okay, a function without name. It acts like a def function name of input, right? So similar to that, it will also act in terms of function level. Okay, so we call it as a anonymous function. So this lambda x, what it is doing, it is going to take your each element from your ARDD as input. Okay, that means x is, let us take an example, x is 1 and then 2 3 4 5. So you will get iterated all the elements into this function. Okay, lambda is an anonymous function which will be used inside the transformation of RDD. Okay, even if it is a map or flat map, any transformation, you can use this lambda function. Okay, so the reason why we are using this function, so the use case is I want to see what are all the even numbers in my RDD. Okay, I want to filter only the even numbers in my RDD. So that is my use case. Now if you want to do that, you need to apply a filter. Okay, you need to apply a filter, and inside the filter you need to write the logic, right? So filter transformation, it is good. Okay, inside the filter you need to write the logic, right? So that logic you will write using this lambda function. Okay, now lambda x meaning each element from the RDD, each element from the RDD. Be very very clear. So lambda x meaning each element from the RDD. That means I have 9 elements stored in my RDDA. Okay, and from that 9 elements I am iterating one by one using this lambda x. Okay, it is not a sequence operation. Be very very clear, it is a parallel operation. Okay, it is a parallel operation, meaning if your ARDD have 10 partitions that got stored in 5 executors. Okay, assume if your ARDD will be having 10 partitions. Okay, you have taken a large data and your ARDD will be having 10 partitions. Okay, now these 10 partitions got stored in 5 executors, 2 partitions each. Okay, internally your Spark stored like that. Okay, now what will happen when you write this filter transformation? All the executors will run this filter logic on top of two partitions. Okay, executor 1 have 2 partitions,
and it will run the filter logic on the two partitions. Executor 2 will have two partitions. It will run the filter logic on the two partitions. Okay, internally, this is what the behavior. Be very, very clear. But you also can write your Python program to do this. But your Python program will be limited to your machine. You can write a simple function. You can ask me, hey, Venkat, I can write a simple Python function to calculate the even numbers. Why do I need to use Spark? Okay, assume in this case you have only 9 elements. What if you have billions of elements in your RDD, meaning you are reading a billions of records from a CSV file or text file, right? So assume if your data is very big, do you think your Python will be able to process? And how much big machine you need for that? Because your Python is a single machine kernel, right? So it will be having only one kernel which will be running in your single machine. It is not a distributed service. Okay. That doesn't mean that we cannot use Python for data processing. Yes, we can use Python, pandas, all for the data processing. But remember, it is limited. Okay, it is limited. If your data volume is going beyond your limits, right, then definitely you need to use big data frameworks called Spark. Okay, so that is the major difference that you need to understand, guys. In the starting itself, I'm giving you major, clarifications. Okay, be very, very clear in this. Okay, in interviews, people will twist the questions and ask you. Okay, so they'll say like, okay, so why you need Spark? You can write the SQL, you can write the Python, and why you need Spark for it? I can write all these things in SQL and Python also. That the immediate answer should be, your SQL and Python are not distributed parallel processing frameworks. Your Spark is a distributed in-memory parallel processing framework, which has been developed for big data processing. Okay, it is for big data processing. It is not for your small scripting tasks. Okay, so, and remember, wherever it is useful, there only we need to use Spark. Okay, if you have very small requirements like small file processing, let us say you are getting files in KBs, okay, then you don't need Spark at all. Okay, you don't need Spark at all. Be very, very clear. If you want to process very huge files, and if you really have a big data in your project, then definitely your architect will involve your Spark framework. Okay, it is not your decision, or it is not my decision, guys. Your solution architect will take the decision. Okay, so how much data is coming into this project, and which service do we need to use for this implementation? Every decision will be coming from the solution architect. Okay, according to the architect's decision, the services will be decided. Okay, now majority of the projects will be having very huge volumes of data, no doubt in that. Okay, so let us take an example. In my case, I'll be getting around 500 GB data per day. Okay, and if I want to process 500 GB of data per day, assume if you write your Python code, will it be able to process? No, right? Even though if it is able to, but how much time it will take. So that is where the Spark comes in, right? So every day, how much data you're getting into your system, and then how to process that data every day, and then store the results into reporting tables, and reporting will be happening seamlessly. So how you will build this system is important. Okay, so that is where Spark performance comes into the picture, guys. So just to give you more clarity, I've discussed all these things. Okay, so this is how you apply a filter transformation. So lambda x colon x percentile 2 equals to 0. Okay, now this is the logic for identifying the even numbers. So the same thing, right? You will put it in a function, right? So def find out even of x. So you'll pass the x input, and then you'll iterate each and every element, right? For I in list, and then call that function and then pass I to that function. In Python, you will write like that. But in Spark, this is the flexibility that you have. You can finish that in single line. Okay, you can finish that in single line. So, and that too, it runs parallelly. That too, it runs parallelly. Okay. See here, I just ran this transformation and then it used collect to see what is there in my BRDD, and then I got this output. Okay, this is the filter transformation. And then next two important transformations that we are going to see are map and flat map. Okay, map and flat map. So map and flat map are the transformations in Spark, which will be which can be widely used transformations in projects. Okay, so let us quickly understand the difference, guys. Let us quickly understand the difference. So map transformation will give you one-to-one result, meaning how many elements are there in your RDD. Those many elements will be returned with the transformed output. Okay, with the transformed output. But your flat map will return only the single data collection, and the number of elements are one too many. Okay, the number of elements are one too many. Let us understand the difference, guys, here by seeing the output. See here, I am parallelizing my data collection. Okay, and I created my RDD. Okay, you can directly use the transformation, guys. You don't need to store it in a different variable and then use map. That's one way. And you can here you can use like this also. That's the flexibility in Spark. Okay, you can use map transformation. So map is the transformation, and then you are using anonymous function, so we know what lambda x will do. So it will take every element into the loop. Okay, and then here what I'm doing, I'm saying 1 comma x. Okay, I'm saying 1 comma x. Okay, now if you see your map transformation output, so what is the output that I got? I got the list of lists. Okay, list of lists, right? That's what I'm doing. And how many elements that I have? 3 4 5. And how many elements that I got in my output list? 1 2 3. So three elements. So 1-to-1 mapping. Your map transformation will be 1-to-1 mapping. You will get, I mean, how many elements you have, and you will get those many elements as output, and the transformed output, meaning whatever the transformation logic that you will apply here, you will get the data accordingly. Okay, you may apply regex transformations, you may apply the filter transformations, or you may apply all the if else loops. Everything you want, you can write it inside this map transformation. Okay, so fine. So that is what the map transformation is. See here, but when you say the flat map, the same functionality, your flat map has returned single data collection. Be very, very clear. Okay, your map will return list of lists, because it has 1-to-1 mapping. I mean, one element, one output element. One element in the RDD will result one output element. Okay, but in flat map it is one to many. So your one element will be multiple output elements. Okay, so here if you see, your entire data collection will be flattened. So that's what we'll call it as a flat map. It also works like similar to map only, but it will give the flattened results. It will give the flattened results. Okay, so flattened meaning, so it won't return list of lists. It will return single list. That's it. Okay, so guys, are we clear with map and flat map transformations?
Yes, sir.
Okay, so your map will return list of lists. Your flat map will return flatten list. Okay, flatten output from the map transformation. That's it. It's very simple. Okay, so these are the map and flat map transformations. And let's see one more example. See here. So I'm just trying to say, uh, I have taken the data collection 345 again, and I'm saying map of x comma x into x. Okay, map of x comma x into x. So control enter is the execution trigger, guys. If you want to run this cell, you can go and click this. Okay, or you can quickly press control enter, so that your cell will run. This particular thing we call it as a cell in the notebook. This entire thing is the notebook, Jupyter notebook, Pyspark notebook. Okay, and in this notebook you have a cell. Okay, each cell you can run separately. Okay, fine. So here if you see what I'm doing, I'm just using the parallelize method, and then using the map transformation, and I'm saying lambda x anonymous function, and I'm just saying x comma x into x. So the output will be 3 comma 9, 4 comma 16, 5 comma 25. Okay, now in the similar fashion I'm just using my flat map. So see here, you got the flattened results. Okay,
Yes.
and the next transformation that we're going to see is the distinct. Okay, so distinct is another transformation on top of the RDDs, wherein you can eliminate the duplicates from a data collection, or from a RDD. Okay, from a RDD. Okay, so here if you see, I'm just creating an RDD from list of strings. Okay, and then I'm using distinct on top of my RDD. Okay, I'm using distinct on top of my RDD, and then I'm using the collect method to see what is there. So your distinct will remove the duplicates, and then it will return the data. Okay, so that is the distinct. So we have distinct in SQL also, so the same functionality, but on top of the RDDs. Okay, so the next transformation is the Cartesian. Okay, so Cartesian is a product, right? So I mean it's a Cartesian product, we know, right? So similarly on top of the RDDs, if you want to apply this kind of a Cartesian functionality, you have a Cartesian transformation on top of the RDDs. So here if you see, I have a RDD called x and y. Okay, and here if you see 1 2 3 4 5 6 7 8 9 10, so two RDDs I have, and I'm saying x dot Cartesian of y. Okay, so when I say collect when I say collect, so what it will return, so it will return list of tuples, and it is a RDD again. So list of tuples you will get, so 1 with all the elements 1 6 1 7 1 8, right, 1 9. Similarly 2 6 2 7 2 8. So all Cartesian product you will get. Okay, that is about the Cartesian transformation. The next thing is the collace. Okay, so collace is another transformation where actually you can play with the partitions of your RDD. Okay, you can play with the partitions of your RDD, meaning when you are creating your RDD, you can always see the partitions of your RDD. Okay, so let us take an example. Here I'm just creating one plain RDD, and I'm seeing the number of partitions that my Spark has created internally. Okay, by using the get num partitions. So this is a method to see how many number of partitions are there inside the RDD. Okay, now when I run it, see here I got two partitions. Okay, I got two partitions. Okay, so by default your Spark has created two partitions for you. Okay, now if I say here 5, okay, if I say here 5, then what will happen? It will create 5 partitions, guys. So here what you're specifying inside your parallelize, you are specifying the number of partitions. You have a feasibility to specify the number of partitions also. Hey, take this data collection and put it in 5 partitions. Okay. So why partitions matters, guys? So because of the partitions only you will get the parallelism. Okay, because of the partitions only you will get the parallelism. How many number of partitions are there? That much parallelism you will get. Okay. Now I got 5 as a partition number, so it created my 5 partitions. Okay. Now if you see here, I'm creating a Z RDD. Okay, I'm creating a Z RDD and I'm using a Coles transformation on top of the Y RDD, and I'm passing Coles of 2. Okay, that means I have 5 partitions initially in my RDD, and if I want to reduce my partitions, then I can use Coles transformation. Okay, then I can use Coles transformation. So you see here, I'm just using get num partitions of Z, then immediately it got reduced to 2. Okay, so similarly, if you want to increase the Coles, increase the partitions, will your Coles work? Remember, it won't work. Okay, remember, it won't work. Your Coles transformation is only for reducing your partitions from the parent RDD. It is not for the increasing. Be very, very clear. Okay, so now you can simply see what is there in the Z. Okay, so here if you see, I am just saying Coles of 2. Okay, so your Z also will be same, looks like same, right? The reason being, you are not doing anything with the data, right? So you are doing with the partitions. So end of the day, when you do collect, it has to go and collect all the data from all the partitions, right? So that's why you are seeing similar to Y, you got Z also. Okay, so these are few transformations, guys. So today we have seen few transformations, right? Coalesce, Cartesian, distinct, map, flat map, and we know how to create RDDs, right? So we know how to create RDD from a data collection. We know how to create RDD from a file, right? So that, I mean, just try to practice all these things. Okay, so tomorrow we will quickly complete all the transformations and actions that we have. Okay, and then the next concept that we're going to discuss is accumulators and broadcast variables. So these are some things that we need to discuss. So we'll discuss on accumulators and broadcast variables, which are very important in real time when we are working with variables. Okay, and after that we will try to go for the script based execution, or else application based execution. So how we can read a text file and process it and write it into output file. So these things we will see after these things, because these are the basic things. Once you have this basic things understanding, then it is good to go with the application. So what is there in the application, guys? You will put all these statements into the sequence like a program. That's it. If you don't know what these functions are, then how you will utilize those functions in the script, right? So tomorrow we will focus on group by key, reduce by key, and then join major transformations that we have, right? So we will see all those transformations, and then we will try to understand the internals. Okay, that's all I have for today, guys. Any questions or queries? Please ask if you have any confusions, guys. Don't keep confusions. Hope everybody able to understand.
Yes, sir.
Yeah.
Okay. Ranganath, Prakati, Anusha, are you able to understand?
Yes, Vincent.
Okay, fine. That's all I have for today, guys. I will share this this entire what I can say the notebook. You can quickly upload it into your clusters when you're practicing. Okay, so I'm just trying to. I don't know where to send it because I don't have attachment in my. Okay, because we have the Git repository, right? Let's upload GitHub. Just a minute. So let me upload it into the GitHub so that everybody can access this. So I want everybody to practice this, create your cluster and then practice your RDDs, guys. Okay. So here in this GCP dev, I'm trying to upload this. I don't know whether I have this Git installed. Okay. So I'm trying to upload the RDD examples file here. Okay, so it's a notebook file. Okay, so try to go here and access this, guys. Check if you are able to access. Someone confirm. Let me paste this. Check if you are able to access this.
Yes, one we can have.
Okay, try downloading that file, or try downloading the file that I added now. Are you able to do that? So once you click on this file, you will get a download option here. Are you able to download it?
Yes, Vinci.
Okay, so once you downloaded, what you need to do, guys, once you go into the cluster Jupyter lab, you just need to upload that file here. Okay, you can directly see the content like this and you can execute. Okay, so that is something that you need to do. Okay, fine. Thank you so much for joining. Once again, we'll connect back tomorrow and we will try to complete the RDD based functionalities. Okay, thank you so much.
Thanks.
Thank you.
Thank you.